and welcome back to Vedantu Daily Sessions. Guys, we have completed 3 sessions of acids and bases already, and this is the very next session, that means the 4th session. Okay, so far we have spoken about the definitions, classification of acids and bases. Also we spoke about indicators in the last class, especially those color based indicators. Today we'll be continuing with the same topic of indicators followed by the pH concept. Okay, but in case you have missed my videos before and this is the first time you're in my session, this is Dr. Nazma and I teach chemistry. Let's get started without any more delay. What are indicators? I told you already in the last class, so now it's your turn to define. Can you define indicators? What are indicators? Indicators are the signal indicators. No, something very close by, something which works with the same principle, correct? Indicators are the substances which work or which try to help us identify if the given substance is an acid or a base by changing color or by changing smell. In the last class, we spoke about all those indicators which change the color and help us identify the substances. Like we spoke about phenolphthalein, methyl orange, right? Litmus indicator, turmeric indicator, etc. In today's class, we are going to talk about those indicators which do change their smell and help us identify the given substance. And those indicators are technically called as olfactory indicators. So olfactory indicators are the ones which have a different odor or smell in presence of an acid, and they immediately change their odor or smell when you add it to the base. So with the help of that smell change, we can identify. So let me give you a few examples of those olfactory indicators before we could talk more about it. So how many of you know what onion is? Everyone knows onion, correct? We use it in the kitchen. So have you ever smelled onion? It has a very strong smell, right? You know the reason behind the smell of onion? Onion is rich in sulfur. Sulfur, the element. So sulfur containing compounds are usually odd smelling. Okay. So onion, because it contains sulfur, it has that strong and pungent odor. Now the onion or the extract of onion, extract as in the juice of onion, has capacity to act as an olfactory indicator. In presence of an acid, it does not change its smell, but in presence of a base, it just changes its smell completely. Like the smell gets vanished. It does not get changed into something else, but the smell gets vanished in presence of a basic medium. Similarly, you know essence, vanilla, right? Vanilla essence. We use it usually in making of cakes or ice creams and all of that. In fact, that vanilla extract is extracted out of a plant, vanilla plant. So it has a characteristic pleasant sweet smell. Even vanilla essence has the same behavior. In presence of an acid, it doesn't change, but in presence of a base, the smell vanishes. So onion, vanilla, clove oil, the cloves, you call it as long in Hindi. It's a medicinal thing, but moreover, it also can act as olfactory indicator. But then know one thing, that these olfactory indicators are very commonly existing along with us, right? Like they are easily available. The onions or maybe vanilla essence or maybe clove oil. But still we don't use them in laboratory as actual indicators, or during actual titrations or reactions, we don't use them in lab. Can you tell me the reason? I must have mentioned it once or twice ago in the previous videos that you cannot dare to smell the chemicals randomly. Until and unless you are not sure about the reaction and the chemical, you should not smell it. It's dangerous. Why? There are so many chemicals which are toxic or poisonous when inhaled or consumed. Moreover, the other chemicals are also not any good. They have capacity to dehydrate your mucus lining in the nasal cavity, also in the bronchus. So maybe mild irritation to a strong irritation can be caused. So which is all troublesome, right? We have to always try and avoid any sort of contact with the chemicals, maybe through the smell or maybe touch or taste. So we shouldn't do it. That's why we don't use olfactory indicators in lab. We use the color changing indicators, which are always safe enough to be used. Alright, so this is about indicators, and having indicators is like a blessing, because without indicators we can't identify the substances. It's very, very not possible. Alright, now let's go to a fresh page and I'll give you some examples now. Before we could go to talk about the next topic, the pH concept, I'll give you some examples. Okay, so you listen to these examples. Example number 1, the container has become too small. I'll take another. So here is a container, and this is the second container. Now assume that the first container is consisting of an acidic solution. Okay, this is an acidic solution. And the container 2 is also consisting of an acidic solution. Done. Container 1 is an acid, container 2 is also an acid. You know what? In spite of starting with acids, let us start with something more familiar. Okay. Now just erase about these containers. Again start listening freshly. I have two containers. Container 1 this time is consisting of sugar water. Isn't it more familiar? Sugar water. Second container is also containing sugar water. But in case of first container, I have taken 100 ml of water but 1 spoon of sugar. Okay. In case of second container, I have taken 100 ml of water with 10 spoons of sugar. And I mix them very well, very thoroughly. Now, I want you to taste the sample from container 1 and sample from container 2. So now can you please tell me which one will be more sweeter? Such an easy example. I'm expecting right answers from everybody. Is it container 2? Of course, yes. Why? Container 2 is sweeter because it has more sugar inside it. That's it, isn't it? Okay. Now, container 1 is not as sweet as container 2 because it has less amount of sugar inside it. Similarly, if again I talk about the containers, container 1 and container 2, and this time in spite of sugar, I am taking 100 ml of water plus maybe 10 ml of acid. Okay, and in the second container, I am taking 100 ml of water and say 50 ml of acid. In place of sugar, I just have taken acid. That's all is the difference. Now you tell me, I'm not asking you to taste, I'm just asking you to compare the previous example and this example and conclude which among these two will be having more power, more acidic, which will be more acidic. By the way, observe the volume of acid here, 50 ml, so more acidic. Container 2 will be more acidic. Done. What do I call this concept as? 100 ml with 10 ml of acid, 100 ml with 50 ml of acid. Is there some word that we can relate to this? Yes, there is a word. What is that word? Concentrated. This is also not new to you. You know what? You have studied all of these things in class 7, class 8. I'm just helping you to recall. You know everything. Whatever we are discussing, whatever you study in class 10 CBSE, you have everything in the head. I'm helping you to recall. Okay, so this is called as concentrated acid. So what's concentrated acid? Something which has more quantity of acid in the given sample. Then what is the opposite of concentrated? Opposite of concentrated is called as dilute acid. Okay, so now see, assume that this 10 ml of acid is HCl, 50 ml is also HCl. Both the containers are HCl solutions only, correct? But then one is more powerful because it has more quantity of HCl. Other is less powerful because it has less quantity of HCl. So an acid which is given to you can be a dilute acid or can be a concentrated acid. What does this depend upon? Being dilute, being concentrated, what does this depend upon? It depends upon how much acid is present in given volume of water. Right? So now if I have an acidic sample, I can make a dilute sample out of it. And I can also make a concentrated sample out of it. Are you understanding these words? Dilute and concentrated are these words. These are the words which are usually used. You get to use dilute acid, dilute base, etc. etc. in the reactions going ahead. You need to be aware what's dilute. Okay? I hope the point is clear. Dilute and concentrated. Done? So now, I'm taking you to the next page to help you understand some of the very not important but then crucial concept. Crucial as in, it's not asked anywhere, but if you don't know this, you will be under a lot of confusion. Okay, so now previous case was dilute and concentrated. That's different, keep it aside. And now right now it's something else. What is that something else? Say you are having CH3COOH. Can you please tell me the name of this acid? I gave you the formula in first video and I asked you to learn it. Did you learn? What is this? This is called as acetic acid. Where is it present? It's present in vinegar. Okay, done. Now you are having HCl on the other hand. According to the definition of acids and bases that I taught you, according to Arrhenius theory and all of that, remember? Acid is something which has H plus ions inside it, right? So now both of them will release H plus ions. Alright. But to be able to release H plus ions, they should break their bond. Correct? Now, the product will be CH3COO minus and H plus. In other case, it is H plus and Cl minus. Correct? Now you observe something clearly. You know, it's all about your observation. So the molecule acetic acid, CH3COOH, it's a big molecule when you compare it with HCl. Correct? Because the molecule is bigger, it's heavy. It doesn't break down easily. In physics, you study, right? The mass is more, the moment of inertia also will be more. So it doesn't move or it doesn't respond easily. Same applied here. The bigger molecules are, the chained molecules are usually stable and they don't break down. And acetic acid also is in that way stable. Very hard it is to break down this molecule. So if you have 100 molecules of acetic acid, only 10 will break down. Then what happened to 90? They remain as CH3COOH only. So now if I have a beaker or a container which is consisting of 100 molecules of acetic acid, only 10 molecules are giving me H plus. 90 molecules are remaining as they are. But if you talk about HCl, look at the size of the particle. It's very slim and trim. Correct? Breaks down immediately. If I have 100 molecules of HCl, 99 will break down. One will not break due to some weird reason maybe. Yeah, but then 99 molecules are breaking down. Now you just observe these two cases, CH3COOH and HCl. When I am ionizing them, this is giving less H plus ions and this is giving more H plus ions. Correct? Now, less H plus and more H plus. Alright. What is acidity or what is acidic strength? What's an indication of a strong acid? If I ask you what's an indication of a strong body? In a physical fight, like maybe a kusti fight or something, a dangal or something, if the person is doing well, maybe he is physically strong. We have some measures to understand the physical strength, correct? The same way we also have some measures to understand the mental strength. Like if you face the situations and problems with stability, then you can be considered as mentally strong. Similarly, what is a measure to identify acidic strength? How do I know if some acid is strong or weak? How do I know? By observing the number of H plus ions it can give. Acetic acid gives less number of H plus ions. Why? Because it's a big fat molecule. It doesn't break down. It's too lazy. Then HCl is very slim, trim, fit, everything. 99% of the molecules will dissociate. So more and more and more H plus concentration. The more is the amount of H plus released by an acid, more is acidic strength. So now out of these two, can you please tell me which is a strong acid and which is weak acid? Okay, for the ease of you answering, A and B. Out of A and B, which is stronger? HCl is stronger. Why HCl is strong? Because it's giving more H plus. Okay, so what? Array number of H plus ions is the measure to identify the strength of an acid. Okay. Similarly, if I want to identify if the given base is a strong base or not, then how do I identify? How do I get to know if the base is a strong base or a weak base? For acids, it is H plus. For bases, you observe OH minus concentration. If the base is giving you more OH minus concentration, after dissolving into water, underline this word, after dissolving into water, only after dissolving into water, you will get to know all this story. Okay? More is the OH minus concentration, more strong is the base. Like NaOH is a strong base. KOH is a strong base. Less is the concentration, less is the strength of the base. Example, ammonium hydroxide. It's a weak base. So what did we understand till now today? We understood two classifications of acids and bases. Classification number one, do you remember? Acids can be classified into two types. One is concentrated acid and other one is dilute acid. What is concentrated? Concentrated acid is an acidic sample which is containing more, write it down, more amount of acid. I'm talking about amount of acid per maybe unit volume of water. Okay, in the given solution, if you have more acid, then it is concentrated. If you have less acid, then you call it as dilute acid. And concentrated and dilute depends on you. if you have a concentrated acid, you're adding some 2 jugs of water to it, what will become? It will become a dilute acid. You can change the concentration. You can let an acid be a concentrated acid, or you can let this be a dilute acid. It's in your hands, okay? But the second classification that we have done says that acids are classified further into 2 types based on how many H plus ions can they give. One is strong acid, other one is a weak acid. This applies to bases also, but I am choosing acids to explain this better. So strong acids are the ones which ionize to give more H plus. What is a concentrated acid? Which has more amount of acid. What is a strong acid? Which can give you more H plus ions. Both are entirely different. Are we clear with this difference? Are we? Can you make an acid a strong acid? No, it's not in your hands or my hands. Then it's the behavior of acid. It's how strong the acid is. It's how quick it can ionize, how many H plus ions it can. It's the behavior of the acid. Okay? Concentrated and dilute, it's the tendency of us to add more water, to add less water, etc., etc. Okay? This is internal character of acid that is influenced by external people like you and me. Are we clear? Examples of strong acids. All mineral acids are strong. Almost all. Not all. Yeah, almost all mineral acids are strong. HCl, H2SO4, HNO3, H3PO4. Making note of these things, right? Followed by weak acids. Example, all organic acids are weak. That's why we eat them. Oxalic acid, lactic acid, citric acid, ascorbic acid, folic acid. All organic acids. Alright. Similarly, strong bases NaOH, KOH, weak bases ammonium hydroxide, NH4OH. Okay. So these examples that I gave you are the basic examples that you should know, guys. Because these terms, these formulae, these examples, you get them repeatedly in your syllabus going ahead. So whatever I'm asking you to learn, please make sure you learn them, because they are the bare essentials. Okay. Bare essentials as in, yeah, don't go over the brand here. I'm talking about the essential info that you need to know. Done? And some of you in the comments of the previous video asked me about the list of chemical reactions, list of chemical formulae which are needed for class 10 CBS. There's a book in which all these lists are already present. It's an e-book. It's available in Amazon also. You can take a look at that book. It has all the info, all the listed out formulae, common names, colors of the compounds, also the chemical reactions and the observations of chemical reactions with important questions for your board exams. Yeah, you have long time for your boards, but then yes, you should start preparing from now. The name of the book is Score Booster, CBSE 10 Chemistry Score Booster. Okay, so if you need the link or something, you can ask me in the comment section. I'll try to find the link. Alright, so guys, this is about today's video. We have understood what? We understood olfactory indicators and we understood the classifications of acid. You know what? Whatever I'm trying to cover up in these videos is something which is not there in NCERT. But still, this is needed. See, the strong acid, weak acid concept, you will have questions based on it. But if you look at the description in NCERT, no, it's not given. If you want, you go find it now. Similarly, the previous classes we spoke about, we understood dilute concentrated concept today. Previously, we spoke about various other concepts, the flow charts and all of them. They are a part of your syllabus, definitely, but the way it's given in NCERT is not enough, or it doesn't help you understand completely. It's a textbook, right? NCERT is a textbook. It doesn't give you everything. You need to get everything from different sources. So I'm making sure my videos are helping you in that way. But then in case you have any suggestions that you want to learn something outstanding or some other topic from me, don't hesitate letting me know. If I can do, I will do. If I can't do, then that's different thing. But whatever I can do, I'll definitely do it for you. Alright, so I'll wait for your comments, I'll wait for your requirements, and those of you who asked for periodic classification videos, it comes in the sequence. Once we are done with chapter 2, 3, 4, I'll come to chapter 5. Okay, periodic classification, but then yes, it will be covered. Done? So alright guys, then I'll see you in the next video, and I'll start the concept of pH, which is dependent upon this strong and weak acids wala funda. We'll talk about pH in the next class. Until then, bye.